Today, we're going to learn how to use the Deque data structure. Hello, I'm James Helfrich. Deque means double-ended queue. The traditional implementation of a Deque is just that, a double-ended queue. I can have access to either end of the Deque, but not the middle. So I can push to the back or pop from the back, or I can access the back, and same thing from the front. But the C++'s implementation of the Deque is a little bit different. We have random access to the square bracket operator to any element in the middle as well, and to do so efficiently. So let's take a look at how C++ implements the Deque. There are a large number of constructors for the Deque, including the default constructor, the copy and move constructor, the size constructor, and the initializer list constructor. Okay, in order to use the Deque, we first need to pound include Deque, and this is going to give us access to the Deque library. Now, in order for me to create a Deque object, I need to say std::Deque, and then the square bracket, and then the template operator, and then mine's going to be a Deque of integers. When I do this, my Deque is going to be of size 0. So when I break into the debugger, we're going to see that this is of size 0. All right, now I'm going to use the initializer list constructor, and so I'm going to put 6 values in here, and you can put them in any order you want. And then when I run this, we're going to see that my size equals 6, and the order in which I specified the elements is going to be preserved. And they're preserved sure enough, and this is of size 6. Now I can also do a copy constructor, so I'm going to make my Deque source, which is my initial values, and then I'm going to make a destination, and here I'm going to pass in the source, and all the elements from the source will be copied into the destination, giving me 2 distinct copies of these 6 elements. And they both have the same 6 elements. Now I can also use the move constructor, and here I'll specify std::move, and this will steal source's elements into destination. So source will be of size 0, and now destination will have all 6 of source's previous elements. So source is empty. Finally, I can do the size constructor. I can say, hey, give me 4 elements in the Deque. And when I run this, we're going to see that there are 4 elements, each initialized with a default value of int in this case, which is 0. And then I can say, hey, actually initialize them to 99, so now I'll have 4 99s. And there they are. There are a large number of assignment operations for the Deque, including the copy assign, the move assign, the initializer list assign. I can also assign a collection of values, and I can swap values. To demonstrate this, I'll have my source and destination Deques, and if I say destination equals source, then I'm going to copy the values of source on top of destination, which will remove destination's previous 3 values. And sure enough, both are a size 4, and both have the values 20, 40, 60, 80. Now I can also do std::move, and this will steal source's values into destination, so source will now be empty, and destination will have the 4 elements 20, 40, 60, 80. And sure enough, source is empty, and destination is empty. All right. I can also swap, and I say swap, I'm going to swap destinations with sources, and now I'm going to expect destination to have 4 values, 20, 40, 60, 80, and source to have 3 values, 11, 22, and 33. The Deque has a full complement of iterators, a forward iterator, a constant iterator, a reverse iterator, and a constant reverse iterator. The full name for the iterator is std::Deque int: iterator. I'll call it it for short. D.begin will point to the first element. Now the first element is going to be 20, and it will refer to the 20 element, and sure enough it refers the 20 element at index 0. Now, most people don't want to type the full name, so I'll just say auto it, and since begin returns a iterator, it'll take care of the declaration for me. Okay, so I can do the standard iterator for loop for auto it equals Deque.begin, it not equals d.end, and ++ it, and this will iterate through all elements in the Deque. And I can access an individual element that the iterator points to with a dereference operator. And so I'll say star it. In this case, I'm going to change the value by multiplying it by 100. So now instead of 20, 40, 60, 80, I'll have 2,000, 4,000, 6,000, and 8,000. And there we go. The deck has a wide variety of access elements, including the traditional front and back, but it also has a square bracket operator normally reserved for the array. So I'll take the same 4 elements in my deck, and I'll be able to access the front element with d.front, and I'll be able to access the last element with d.back. I can also access a middle element. In this case, I'll access element 40 by saying d square bracket element 1. So element 0 is 20, element 1 is 40, and so on, because remember with arrays we always start at 0. And when I run this, sure enough, front is going to be 20, back is going to be 80, and 40 will be 40. Now, front, back, and the square bracket operator are not just read-only, but they also allow me to modify. So in this case, I'm going to assign the front to 2, and I will assign the back to 8, and I will access element 40, or a d of 0, to the value 4. Oh, I forgot my semicolon. I'm full of typos today, aren't I? There we go. And now when I look at the contents of the deck, we'll notice that I'm no longer 20, 40, 60, 80, but I'm 2, 4, 68. The traditional implementation of the deck only allows me to push elements onto the front and onto the back. However, the C++ version allows me to insert elements in the middle, as well as to resize to an arbitrary size. So I'll start with 4 elements, 20, 40, 60, 80, and then I'll say push front, and I'll push onto the front the value 10, and I'll push onto the back the value, what should I push on the back? How about 100? And when I run this, we're going to see I no longer have 4 elements, but now I have 6. It's me 10, 20, 40, 60, 80, and then 100. Now I can also put elements in the middle. And the way I'm going to do that is I'm going to get an iterator, and I'm going to say, hey, iterator is d.begin, which is going to point to 20, plus plus, which return to 40, and I'm going to insert the value 99 there. And this will put 99 before the location that it points to. So right now it points to 40, and now when I insert 99, it'll be before 40, so it'll be 20, 99, then 40. Now a cool thing about the deck is I can resize it. So I'm going to resize to 10, and so I was 4, now I'll be 10, so it's going to fill in the balance 6 items with the number 0, because that's the default integer. And I can also change the default value from 0 to 99. Now I'm still going to add 6 elements to the end of the deck, but they're no longer going to be 0s, they're now going to be 99s. Now, I can also change the size of the deck from bigger to smaller. In this case, I'm going to go from 4 elements to 2, so the 60 and 80 elements will be erased. And now there's only 2. The traditional implementation of the deck only has pop front and pop back, and some have clear, but the C++ implementation also allows us to erase elements in the middle. So I'll start with 4 elements in my deck, and I'll say d.pop front, which will remove the 20, and then I'll say d.pop back, which will remove the 80. So now I should only have 2 elements in my deck, value 40 and the value 60. And sure enough, 40 and 60. But I can also use the iterator to remove a specific element. So now I'm going to point to the value 40 by d.begin and plus plus it, so now I'm pointing to 40. And now when I see d.erase, I'm going to erase it, and that will remove value 40. Oops, I put my semicolon in the wrong spot. Haha, silly me. There we go. So now I should be 20, 60, 80, size 2, now that 40 is gone. And it is. Now I can also erase a range of elements. Now remember, it still points to 40, and I'm going to go from 40 all the way to the end. So let's remove 40, 60, and 80, leaving only 20. And last, I can always remove all elements of the deck using d.clear. And now size is 0, and there's no elements. Deque has two status functions, size and empty. So to find these, I say auto s equals d dot size, and so this is going to return a size t, which is an unsigned int, and auto e equals empty, and that's going to be a Boolean value. Now the size should be 4, and the empty is false. Now I'll do the same thing again, calling the default constructor, and now size should be 0, and empty is true. Notice how the unsigned int is my size. You can learn more about the Deque, including how to solve problems with the Deque and how to implement the Deque in the C++ data structures textbook.